Hi everyone, Mr. Ford here. We are going to continue with electric circuits. So far, last week we completed series circuits and parallel circuits. Today and Wednesday, or depending upon the day, the next 2 days, we are going to work on combination circuits. Combination circuits are just like the name suggests, a combination of both series and parallel, meaning that some resistors are in series with each other or with the battery, or in parallel with each other or the battery. So we're gonna have to use the two different sets of rules accordingly, depending upon how the resistors are situated. So there's a couple methods we're gonna go through. The first, you definitely see the instructions on the packet page. You can go through that way. I'm also gonna do an additional one that's not written out, but it's something that I still remember from my junior year of high school that my physics teacher taught us. So, as the instructions suggest, take a look at the circuit. We definitely see that resistors 2 and 3 are in parallel with each other, meaning that the current can go through either or. So, if the current was coming out of the bottom part of the battery going through, the current can go through resistor 2 or it can go through resistor 3. It has an option. But notice when it comes back around the other side, that current would then again join. Think of it again as roads and traffic. So whereas resistor 2 or 3 has more or less traffic, when you would go back into another road, the traffic would start potentially being bad again. So all the cars or all that current or the electrons still have to go through resistor 1 to get through to the other side of the battery. So that's the first thing to recognize, which resistors are in series and which ones are in parallel. So we definitely see resistor 1 is in series with the battery because there's only one path to go through it. The current has no other option. And then resistors 2 and 3 are in parallel. So as this instruction state, you draw a box. I tend to draw circles. And we're going to combine those two. So just putting the numbers in the chart, we have a 12 ohm resistor here, 24 ohms at resistor 2, and 12 at resistor 3. So resistor 2 and 3, they're in parallel, so we're going to add the inverses. So this is where you'd hit 24 inverse button, or 1/24th plus 1/12th, hit equals on your calculator, and then hit that inverse button again. And that would give you a total for those two resistors of 8 ohms. Which, since there are two options, the total of those two resistances would be less. So the next thing that the instructions suggest would be to redraw the circuit. So we're going to act like we only have two resistors. This one being R1 at 12 ohms, and we'll call this one R2 slasher comma 3 of 8 ohms. So then it's easy just to get the total resistance as we add 12 plus the 8 to get a total of 20 for the whole circuit. And then we could go through and find the individual voltages and currents, just like we did before. Before we go into that, though, because I think it's a little bit easier to complete it within the chart. So what my junior year of high school physics teacher taught us was to write it on a line. So since we saw that R2 and R3 combine, right on this line, we're going to write the totals. So if you see something written not necessarily in the box, but between the two boxes, we understand that we were kind of like tracking our work and showing these two things combined. So for our 24 and 12 ohm resistors at 2 and 3, their total was I'm going to put that in pink too, 8 ohms right here. So again, when we have our combination circuits, we can't just go down our resistor column and add, because we're only going to add the 12 and the 8, because again, we now redrew it as this series circuit. We kind of condensed it down. So that's basically what we're going to be doing when we have these combination circuits, is condensing everything down into a series circuit to find the totals, and then expanding them back out to find each individual resistance, or not resistance, but current and voltage. So just like before, to find the totals, we have 60 volts total, 20 ohms of resistance, so Ohm's law V equals IR. Simply 60 divided by 20 is going to be our 3 amps. Now, if you remember for series circuits, the current is the same everywhere because it's only one path or one road or one hallway or one river or pipe, depending upon the analogy that you use. So looking at this kind of path, there is only one path. So at resistors 1, 2/3, the current's going to be the same. So it's going to be the same 3 amps of resistance at 1 and 3 for that total. Again, this is our like 2/3 resistance or resistor here. So again, following Ohm's law, 3 times 12, our total resistance for, our total voltage, sorry, for resistor 1 is 24. I'm sorry, basic math. 36. We see that right on our line here, let's actually go pink here. So we see that stands out a little bit. This was 3 here, so 8 times 3, this is our 24. And we can go a couple ways this way. So resistors 2 and 3 are in parallel, and the rule for parallel is voltages are the same everywhere because it's like they each have their own path to the battery. So those resistances are going to be 24 because of that rule. And then we can use Ohm's law to figure out the other missing pieces for current. So 24 divided by 24 is 1. 24 divided by 12 is 2. Or what we could do at this point here is conceptually see that the resistance is double. So 24 is double of 12. So where there's more resistance, there's going to be less current. So since it's double the resistance, it's half current. So if the total is 3, we can think through conceptually and say, well, how can we divide up 3? Well, there's really only one option looking at whole numbers, 1 and 2, where 2 is double of 1 or 1 is half of 2, and figure it that way if you would like to do that. So there are some options here, as however you see it, with drawing it out, completing it in the chart. These are kind of like what I refer to as like Sudoku puzzles. The more and more you do, the better and better you get. So there's little tips and little tricks to figure out how to complete the chart. And what we have left is power. Power is not different if we remember for series or parallel. It's however much energy was used per time. So it's still that VI equals P. So 36 times 6 is 108. 24 times 1, that's easy, 24. 24 times 2 is 48. And again, that power check still applies here. So if we take 60 times 3, that should be the same as all of our powers added up. You could double check my math if you don't believe me, and we should get exactly 180. And again, moving forward, if we are slightly off, like 179 and 181, if you have decimals in your actual verb chart as far as voltage, current, resistance, because you rounded, you will have somewhat different totals as far as power goes. So you may be a little off, but that's okay. So I'm going to walk through one more for you because this is kind of complex. And I mean, you could show work on the side. It is, again, basic math, and as long as you're following those rules, I don't think it's necessary, but feel free to show all that work if you'd like. I think it's a little bit extra to do since there's so many numbers. So we're going to complete, let's see, combination circuit B. So this is very similar. The only difference is there's an additional resistor, R4, which is in, is it series or parallel? Nice job, Maddie. It is in series with the battery. So resistors 1 and 4 are in series with the battery. Resistors 2 and 3, just like before, are in parallel. So same thing. Feel free to redraw that again, where we had resistor 1, resistor 4, and resistor 2, 3, where 1 is going to be 4 ohms, 4 is going to be 5 ohms. My handwriting is horrible. So now to figure out what the total resistances are. So it's going to be 8 and 9. So 1/18 plus 1/9. Hit your equals button. Then hit your inverse button. And you'll find that that total is 6. So I'm going to go the way that I did it in high school, which I tend to like. And that total is going to be 6 ohms. So you could go around and add up those totals, or within your chart, anything that is combined, you're going to use just that one combined resistance. So it's going to be 4 plus the 6 plus the 5, which will give us 15 ohms. Follow Ohm's law to get the current. So 90 divided by 15 is going to be 6 amps. So that means at resistor 1, resistor 2/3, and resistor 4, the current is all the same. It's going to be that 6 amps. So we got 6 here, we got 6 here, and then combo for the 6 there. So if you have two of those missing kind of veer parts, we can figure out the voltage. So 6 times 4 is 24. 6 times 6 is 36. And you can see I'm still writing on that line because that is the R2/3 resistor, that kind of combo. 6 times 5 is 30. And for resistor 2 and 3, they were in parallel. So whatever the total parallel is, each individual is also that same number. And you can use Ohm's law or conceptually think through that, okay, 18 and 9, double and half. So the one that has more, the double, it's going to be half the current. So let's see, 18 is more, so that's going to be 2 and 4 because that adds up to 6. The one thing to note, though, is in series and parallel, we can kind of use our voltage, current, and resistances within the chart and simply add, or however the rules were, to find the totals down here. Here, you need to be a little bit more aware of the scenario of how these are going to look, because we're not going to simply just add this column to be 90. What we would do is say, well, what was in series? For series, voltage added, so 24 plus our 36 plus our 30, we would get 90. So that's how we're going to play that. Power, no different. Again, just V times I. So our 144, our 72, our 144, our 180, and our power check, making sure both 90 times 6 and all of our individual powers add up to be 540. We should get the correct answer. So again, this is one of those things that practice makes permanent. You'll see the patterns and the routines. So again, on your own, I want you to try combination circuit C. In a second, I'll scroll down, or you can check on Schoology for the solutions. Hopefully you get them right. And if you're all good to go, you can try the 2-question Schoology quiz. If you're not and you have questions, feel free to send me an email or Schoology message. This week, we are allowed to start communicating live virtually via Microsoft Teams. So check the link on Schoology to sign up for either office hours or time during our regular scheduled classes. I'll check that the day before or morning of, and I will send you a Microsoft Teams meeting link in your Outlook, your school email. Yeah, I know you barely checked that, but we have to set it up that way. They're not allowing us to send out the link through Schoology. And I'll send another video or information sheet about how to sign up for office hours and how our live classes are going to work. I'll send it out probably at some point tomorrow, meaning Monday. So here are the answers for combination circuit C. Hopefully you're good to go and you can get those Schoology quizzes completed. You do have 2 attempts. If not, be sure to ask me for help. And later this week, we're going to close the books on electricity, and we will start light, which is our last unit. 1 month to go. Wait, so it's from 1 month from Tuesday, I believe your last day is the 28th. Your last learning day or class day is the 27th. So 1 month left for the seniors. Congratulations. All right. Hope to hear from you guys soon.